Welcome back, students. Today we shall discuss about very special topic, and that is dielectrics. So dielectrics are generally insulators, and you know very well what are insulators. We had three types of substances on the basis of electron theory, that is conductors or then insulators, and later on we shall study about the semiconductor, that is third sort of substances on the basis of electron theory. So that's not part of business right now. We shall be talking on the dielectrics. The dielectrics has a very important and very crucial role while the manufacturing of your commercial capacitors, which can store more energy or we can say large quantity of charges. So dielectrics are simply what? Insulators. So I must have a simple definition. They are insulators but they have got a very important property, that is they can produce electric field or they can transmit electric field within themselves. So that is going to play a very crucial role today. So which transmits what? Electric field. Now something is hidden in this definition. It is only talking about transmission of electric field, but no movement of electron will occur inside the dielectrics. Okay, so because they are insulators, they do not have any free electron more especially, but they can produce some effects when placed in some external electric field. That's it. Okay, so let's go into the little more deeper sense of the dielectrics. So generally dielectrics are of two types. One is called polar dielectrics and the other is non-polar. Okay, the polar word comes from the poles. You know what poles are? Negative pole, positive pole, or cathode, anode. In the study of cells we generally use this sort of terms, but here pole means charges, negative charges and positive charges. So if some or any molecule has a positive sense and another part is of negative sense, that is negative charge, then those sort of molecules are called polar molecules, or the molecules forming this sort of dielectrics are called polar molecules. Okay, in fact, for example, okay, before going into the polar and non-polar, we shall discuss about the center of charges. In a single atom, not even molecule, primarily talking about atoms. Atom has a positive core that is called nucleus. Agree? This is a nucleus, and this nucleus is surrounded by different orbits, and these orbits consist of few number of electrons. Okay, so now imagine the positive nucleus of this whole atom has its center of mass lying here, and the negative charged bodies like electrons. Who are the negative charged bodies? Electrons. So if all the negative charged electrons have their center of mass of charges or center of charges is, say, this is noted by the green color, and the black color shows what? The center of positive charges. So this is the atom. This is the atom. If I do say like this, then this atom is polar atom. This atom is polar atom. Now move little more advanced. Suppose I have a molecule, generally it must have two atoms at least. So HCl, hydrochloric acid, consider, or NaCl, sodium chloride. So in sodium chloride, what you have learned is the sodium atom has got a little partial positive charge, and the chloride or chlorine has got little more negative, negatively partially charged, and these charged quantities are separated by some or very small distance. This is if NaCl. So this is sodium, that is the center of the positive charge, and this is the center of the negative charge. So they are separated by certain a very small distance. Then what is that? This molecule has its own dipole moment. And dipole moment P is equal to what? Twice A, that is distance between the positive and negative charges, and multiplied by either of the charges. So obviously in this polar molecule, we are talking about polar molecules or polar atom. Polar molecule, what you see, the positive and negative center of charges are not lying at the same point. So this is having a kind of non-zero electric dipole moment. So all these sort of molecules which have their own permanent electric dipole moment due to the some gap between their center of positive charge and negative charge are known as polar molecules. So now you must have got a little bit feel of the pulse that all those molecules which have their positive and negative center of charges of masses separated by a little more distance, then those sort of molecules are called polar molecules. Okay, so if I have a slab of sodium chloride, then that is a polar dielectric, because in general they don't have any free electron. Suppose I have a piece of NaCl. So obviously this has no free electrons to move through it, but when you dissolve it in water, that produces different phenomena. That's not part of our business right now. So coming back to the idea of polar molecules, that is all those molecules which have non-zero dipole moment are called polar molecules. So we can have four more examples, that is, one is HCl, NaCl. Remember, H2O is a polar molecule. How? This is say O atom and this is H atom, right? So this has got little more negative, this has got some positiveness, a little partially positive charge. So the center of these positive charges is somewhere here, okay, and they finally constitute a dipole, that is, this is center of positive of the two H atoms. So this is the positive center and that is the negative center. So they are forming a dipole. So H2 is a dipole molecule. These are the commonly used or commonly taught dipole or polar molecules which have a non-zero dipole moment. Now obviously if I go to the non-polar, you must be able to differentiate between polar and non-polar. All those molecules which have their center of positive charge, this is the center of say positive charge, and just at the same point we have a center of negative charge. So if the molecules or atom of this sort, then they don't have any permanent dipole moment. So their dipole moment is what? Is completely zero. So the center of negative and positive charges coincide, then those sort of molecules have no permanent electric dipole moment of their own at any situation. So that sort of molecules are called non-polar molecules. All the homogeneous molecules like Cl2, H2, O2. They are of what? Non-polar molecules, because they are center of negative charges and center of positive charges. That is, center of mass of the positive charges and that of negative charges are at the same position. So they do not, what you call, contain any sort of permanent dipole moment. Hopefully this is very simply clear to you, because nothing more, nothing special in this topic. So guys, we have got differentiation between the polar and non-polar molecules. So on the basis of this category, we shall further study that how this polar and non-polar molecules behave when they are placed in the external electric field. That will give us a kind of idea while the formation of what? Dielectrics, and then those dielectrics are used in commercial capacitors. They have a very vital scope in the commercialization of all devices. Okay, so hopefully this is clear. So polar and non-polar molecules. Okay.